Hello friends, this video on light, reflection and refraction part 6 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 5 before going ahead with part 6. So now we will first focus on the image formation by concave mirrors. So we will first talk only about the concave mirror. So let us take the first scenario where we assume that an object is placed at infinity. So how would be the ray diagram in case of object at infinity? So when the object is at infinity, that means the incident rays are coming from some distant point. So we assume that parallel rays of light are coming, right? Because the object is at a very far off distance, we don't know where. So let us suppose that there is one ray which is falling obliquely towards the pole. So what will happen? How will it get reflected? If this is my incident ray, how will it get reflected? It will get reflected obliquely, right? Now let us suppose there is another ray which is coming from the object such that it passes through the center of curvature. So this ray will meet the mirror somewhere here. Let us suppose this is my mirror. So after reflection, what will happen? It will go back along the same path, right? Now, what do we know? Where is an image formed? It is formed at a point where the reflected rays meet. So here, this is one reflected ray and this is another reflected ray. So both these rays meet at this point. So that means image is formed at this point. So this is my image, right? So this is the image which is formed. So what kind of image is formed? We get a real image because in this case the reflected rays actually meet at this point. So what is the nature of the image? It is a real image. It is an inverted image. So if the image would have been formed like this, it would have been an erect image. But since it is formed the other way around, so it is an inverted image. So we got an real image, inverted image, and what is the location of the image? It is formed at the focal length. So that means when the object is at infinity in front of a concave mirror, a real and inverted image will be formed at the principal focus of the concave mirror, right? Okay, now let us look at the second scenario where we say that the object is beyond the center of curvature. That means the object is far from the mirror, but it is not that far. So that means it is somewhere beyond the center of curvature. So let us assume that the object is somewhere here. So let me denote this AB. Let me call the object as AB. It is some object. So now in this case, let us suppose there is a ray of light which goes parallel to the principal axis and falls on the mirror. So according to rule number 1, what will happen? A ray of light parallel to the principal axis after reflection passes through the principal focus. So this is how it will go after the reflection. Now let us suppose there is another ray which passes through the center of curvature. Suppose there is another ray which passes through the center of curvature and falls on the mirror. So what will happen to this ray? After reflection, it will retrace the same path. So what is the point? Which is the point where the two reflected rays are meeting? This is the point, so that means an image will be formed here. So we will call this image as B dash A dash. Now what is the nature of this image? This is real again because the rays are actually meeting at this point. It is inverted again, right? What is the location of the image? So if the object is located beyond the center of curvature, then the image is formed between the principal focus and the center of curvature. What about the size of the image? If you look at it, the size of the image is smaller than the size of the object. The length AB is greater than the length B dash A dash. So the image is diminished. That means it is smaller in size than the object. So this is the nature of the image formed when the object is placed in front of the concave mirror beyond its center of curvature. So I guess now you are understanding, you are getting an idea how do we plot a ray diagram, and these diagrams are known as ray diagrams because we are playing with the rays of light. So it is called ray diagrams. Let us look at the third case where we say that the object is placed at center of curvature. So if you see, we are gradually bringing the object closer to the concave mirror, right? Before it was, first it was at infinity, then it was beyond the center of curvature, now it is at the center of curvature. So that means, let us suppose this is my object. So let me call this object as AB. So here also, now it is not necessary that you have to assume the first ray to be parallel to the principal axis and then passing through the focus. You can consider any of those four rules which I mentioned. You can consider that the ray of light from this is passing through the principal focus and after reflection goes parallel to the principal axis. You can assume that it falls obliquely and then goes back, and you can take any of the two rules. Any out of those four rules, you can consider any two or any three, and you will see that all the reflected rays will meet at a point, and at that point image will be formed, right? So now in this case, let us again suppose that there is one ray of light which is going parallel to the principal axis, and as per rule number 1, it passes through the principal focus. Now let us put the another rule here, is rule number 2. That means the another ray is passing through the principal focus. So after reflection, it will go parallel to the principal axis. So what do we see? They meet at this point. That means an image will be formed here, and we call this image as B dash A dash. So what is the nature of this image? It is again real because the rays are actually meeting at this point. It is again inverted, right? What about the location? The location is center of curvature. That means if the object is located at the center of curvature, the image will also be formed at the center of curvature. And what about the size? If you look at it, the size of the object and the image are comparable. That means they are almost of the same size. So this describes the nature of the image formed when the object is at center of curvature. Let us look at the fourth scenario where we want the object to be placed between the center of curvature and the principal focus. So now the object is still nearer to the mirror. So this is my object AB. So here also let me assume any two rules. A ray of light parallel to principal axis after reflection passes through the principal focus, right? Another ray of light passes through principal focus and after reflection goes parallel to the principal axis. Well, in this case, the diagram is not plotted properly because in this case, the two rays of light will meet at a point which will be beyond the center of curvature. I mean, since here I am plotting the lines, I mean, I'm not plotting it correctly with measuring scales, so it is not meeting at the exact point. Otherwise, this point should be such that it is beyond the center of curvature. So that means you have it B dash and A dash. So in this case, what kind of image do you get? It is again a real image, inverted image, located beyond the center of curvature. And what about the size? In this case, the image is enlarged. If you see, the length of the image is greater than the length of the object. So you get an enlarged or magnified image now. Let us bring the object even more near to the mirror. So let us place the object at the principal focus. So now we have our object at F. So in this case again, ray of light parallel to the principal axis after reflection passes through the principal focus, right? Another ray of light, let us suppose it falls obliquely to the pole making some angle theta. So after reflection, it will go obliquely. So in this case, what do we see? The two rays are going almost parallel and they do not appear to meet immediately. So that means, what do we assume? We assume that these two rays, since they are going parallel, so they will meet at some infinite point. So we say that the image is formed at infinity. So here the image at infinity, because the rays are going parallel. So here I have not drawn it correctly. So this line will go parallel to this line. So the image in this case is formed at infinity. And what kind of image will be formed? Real image, because doesn't matter how much you were far, but the rays will actually meet. So you will get a real image, and the image will also be inverted because it will meet somewhere here. That means it will meet somewhere below the principal axis, and so you will get an inverted image. And what would be the size? The size would be enlarged. That's because the farther away it meets, the greater becomes the size of the image, right? So it will be enlarged. Let us try to bring the object little more closer. So let us place the object between the pole and principal focus. So what happens in this case? A ray of light parallel passes through the principal focus. Another ray of light falls on the pole obliquely and then goes back. So in this case, what do we see? That the two rays don't go parallel. Instead, they diverge away from each other. So that means there is no possibility that they will meet up in future. If the two rays are going parallel, we assume that they will meet up at some infinite point. But if they are moving away from each other, there is no possibility that they will ever meet. So in this case, what do? We extrapolate it at the back, and we see that they appear to meet at this point, and then we say that this is my image. So we say this A dash B dash is the image formed. So in this case, what is the nature of the image? It is virtual, because in this case the rays do not meet actually. The image is erect. What is the location of the image? In this case, the image is formed on the other side of mirror. Till now it was forming, the image was getting formed on the same side of the mirror. Now it is formed on the other side of the mirror. What about the size of the image? It is enlarged, right? So I hope you understood how we decide the image formation by a concave mirror. That means where will be an image formed, what would be the nature of that image, what would be the size of the image. All those things can be decided with the help of ray diagrams. So now this chart tells you, till now we have discussed all different object locations. So this chart is a review of whatever we have derived so far. So when the object is at infinity, the image is formed at the focus, nature is real and inverted, and the size is diminished. As the object is brought little closer, so here if you observe, you see that as the object is brought closer to the mirror, the image formed goes away from the mirror, right? See, the object is brought nearer from infinity to focus, and the image goes from focus to infinity. As the object is coming nearer, the image is going away. And as the object is coming nearer, the image is increasing in size, because when the object was at infinity, the image was diminished. Then gradually the image became of the same size. Then it started becoming enlarged. So the closer the object, the bigger is the size of the image. Okay. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.